Okay, well, and welcome everyone. So in this video, I am going to do another walkthrough, well, a collection of walkthroughs on some problem set problems that I'd like to give, specifically on two-part tariff. So the first couple are just pretty common, are pretty easy two-part tariff questions for identical demanders. Matter of fact, sometimes I like to give this as a quiz question, actually. So this one should have looked familiar for some. So anyway, then towards the end, I do some of the more complicated two-part tariff questions. And so what I'll do is I'll have the solution kind of embedded here with my answer. You probably want to read the question and then stop the video and work it on your own and then look back at it. Same for each of these. So, okay. So suppose we have identical demanders. Suppose all individuals are identical. Their monthly demand for internet access is represented by price is given by 5 minus 1/2 Q with constant marginal cost of $1. So we want to find the per hour rate the firm would charge with two-part pricing scheme, like the optimal per hour rate. Well, we have identical demanders, so the optimal per hour rate is going to be marginal cost. So it's going to be $1. So price will be so when you have identical demanders for two-part tariff, you will set price equal to marginal cost. You'll make 0 on the per unit profit side, and then you'll fully extract consumer surplus by setting the fixed fee equal to whatever that is. That's the structure of what happens here. Okay, so because demanders are identical, we'll set price equal to marginal cost. So my optimal per hour rate is just my marginal cost of $1. Find the quantity the firm will sell. Well, okay, let's just evaluate and define the quantity. So, right. So with a price of $1 solving, this is going to give me a quantity of 8. Find potential consumer surplus. So you could draw this thing, right? So draw this graph. This is going to have a vertical intercept of 5, a horizontal intercept of 10, and then we'll have a horizontal marginal cost line. Consumer surplus is going to be 1/2 base times height. So one side is going to be 5 minus 1. This is the vertical intercept minus the cost. That's always the structure, right, for these problems. And then this right here is the quantity. So literally this should have been like quantity minus 0. It's going to be like the whole base, but I'm just going to kind of omit that step. So it's going to be 4 times 8 is 32, divided by 2, 16. All right, so that's potential consumer surplus. Find the monthly access fee. Well, the tariff fee should equal consumer surplus at that optimal price. So the tariff is the per unit price is 1. The optimal monthly access fee, the optimal fee is 16. And I see this actually I know I wrote that out, so this definitely got deleted. So whatever. Okay. So then we want to find the revenue. Find the total revenue associated with the profit maximizing two-part tariff. Well, careful here. So this is asking for revenue, not for profit, right? So profit is just going to be the 16. Revenue is 24, right? Revenue is going to be the fee plus the per unit revenues. So 16 plus the $1 times the 8 units is 24. What's our profit? Well, the profit is going to further subtract off, right, the 8 units times the marginal cost of 1. So my profits would be 16, but the revenue, 24. Okay, explain the economic intuition. Yeah, this is like two-part tariff with identical demanders. Because we have identical demanders, we can maximize consumer surplus by setting price equal to marginal cost, and then we can fully extract that surplus by charging this fixed fee. And we know consumers are going to pay this price because this is the only way that they're going to have access to the good. So there's no other way to access the good apart from this structure. Okay. So here's the next one. So consider a market in which identical consumers have the following demand for golf. So Q is equal to 100 minus P. So my inverse demand is P is equal to 100 minus Q. Marginal revenue then would be 100 minus 2Q. If I'm just solving for the single price monopoly outcome, it would be 100 minus 2Q is equal to 20, or 80 is equal to 2Q, or 40Q, right? Because I say, suppose the course behaves like a standard monopolist. Marginal cost is 20. What's the optimal price and quantity in this market? What revenue does the firm earn per consumer? Okay, well, to get revenue, we're going to have to multiply. We have, 40 is our quantity, so we'll have to multiply by the price, which turns out to be 60, right? So if my inverse demand is 100 minus Q, and the Q is 40, price is 60. Okay, 60 times 40, that's 2,400, would be my revenue. Now, suppose the golf course wants to be clever, decides to charge an annual membership fee as well as a fee per unit round of golf. Okay, so it's going to have a fixed fee and then a per unit fee. Sets the price of each round of golf equal to its marginal cost of production? Good, because that's optimal for identical demanders. What's going to be the consumer surplus associated with this strategy? Okay, well, 100 is going to be the vertical intercept of my inverse demand curve. 20 is going to be the height of my cost. So one side is going to be 100 minus 20, that's 80, times 80 is going to be my quantity. How do I know 80 is my quantity? Well, at a price of 20, the quantity is 80. Yeah. Okay, so consumer surplus is going to be 3,200. When you set price equal to marginal cost, and marginal cost is 20, consumer surplus, and then my fixed fee would be 3,200. In order to extract all surplus, the firm sets the annual membership fee equal to 3,200. Paying the membership fee entitles golfers the right to purchase rounds of golf at $20 a round. Okay, suppose the golf course charges consumers a flat fee equal to the value of consumer surplus you found, and the fee of golf equal to the price you use in Part B. What's going to be the revenue per consumer? Does the firm optimally employ the scheme, or does it prefer to behave as a standard monopoly? It for sure wants to be two-part tariff pricing rather than monopoly. Okay, so the revenue from two-part pricing is going to be price times quantity plus the fixed component. Price, 20 times quantity, 80, plus 3,200, well, it's 4,800. Now this is revenue, this isn't cost. So the revenue here was 4,800. The revenue under the ordinary monopoly solution was 2,400. So the golf course is able to increase revenue with this clever pricing scheme. Okay. Right. So identical demanders, two-part pricing. The next one, consider a firm with market power that faces a typical inverse demand curve of P is equal to 100 minus 20Q. Firm has a cost function. See if Q is equal to 20Q. Don't let that fool you, right? This is a total cost function, right? See if Q is equal to 20Q. Determine the optimal two-part pricing strategy. How much additional profit is earned by the two-part pricing compared to a typical per unit price? Why does the firm want to offer the two-part tariff rather than only the per unit price or only the fixed fee? Well, right. Okay, so the first thing we want to do is find the optimal two-part pricing strategy. So here's my inverse demand, here's my marginal cost. Right? This is my total cost. Marginal cost is DC dQ. So marginal cost is 20. Let's see. So why does the firm want to do this? So this is the answer to part C. The firm is able to extract all surplus by this two-part scheme. It doesn't want to offer just the constituent parts of the tariff because the consumers will respond to those incentives. And so actually do something that's not optimal from the perspective of the firm. I don't remember if I did I write this out here? I did. Cool. So I'm realizing in the problem set that I've got here, I duplicated a couple exercises. So good. Here is the solution, though, for what we're doing up here as I'm making myself car sick, not in the car. Okay, so here's my inverse demand. Vertical intercept is 100. Horizontal intercept, 5, right? 120Q, so slope of minus 20, right? Here's my marginal cost of 20. So I need to calculate consumer surplus. That's this area right here. So it's going to be 1/2 base times height. Okay, this is going to be 100 minus 20. That's my 80. And then this right here is 4. That's actually Q of 20, right? At the price of 20, what's going to be Q? Okay, so it's going to be 8. This is 20. Move the 20 to one side, the 20Q to the other side. You'll have 80 over here, and then you'll have 20. 80 divided by 20 is 4, right? Okay, so my my consumer surplus is 160. So the fee that I would set would be 160. That's also going to be total profits. What happens with a single price monopoly? That's interesting to explore. So there they'd produce where marginal revenue is equal to marginal cost. So if my inverse demand was 100 minus 20Q, then my marginal revenue is going to be 100 minus 40Q, set equal to marginal cost of 20. So that's going to be a quantity of 2 and a price of 60. The associated profits, 80, right? Profits is going to be price minus cost times the 2 units, or 40 times 2, or 80. So you're actually doubling the profits with the two-part pricing scheme here. And that's further answering part C, which is why does the firm want to do this? Well, it doubles its profits. That's unique to this example. The two-part tariff isn't always going to double your profits, but it'll typically increase profits. Okay, so this is, boy, I feel wonderful about all this. Great. Okay. This was a new one. So did I do this? I did. Cool. All right, so and here I am. I'm like, it's like a major surprise. I'm scrolling ahead to figure out if I solve this problem by hand. You know what I did this? I did this yesterday. Couldn't remember that I did that. So good. Getting old. Also, finished third in my age group in this trail race. So still feel kind of young. All right. Assume we've got 100 identical consumers by participating in a market described by the following demand curve. Q is equal to 900 minus 15p. Assume the market is served by a firm with market power. Find the maximum conceivable quantity and minimum conceivable price for such a firm in this market. Okay. So what's going to be the highest quantity? What's going to be the lowest price? The lowest price is marginal cost. Or, I mean, I guess here I'm trying to argue that it's zero. And then what's the largest quantity? Oh, okay. So sorry. So here suppose the market is served by a firm with market power. What's the maximum quantity, lowest price for such a firm? This is even before two-part pricing. So that's why I'm doing this. I'm just thinking like, what's the revenue maximizing price and quantity? Okay. So find the predicted output and price if the market is competitive and all firms are operating in this industry will share a marginal cost of 20. Does this occur at the elastic, unit elastic, or inelastic portion of the demand curve? Find the predicted output and price if the market served by a single firm with market power. Continue to assume all firms in the industry share marginal cost equal to 20. Find the associated producer surplus profit at this outcome. And then suppose we want to employ a two-part tariff. It'll charge the fixed membership fee and a per unit price, assuming the demand curve indeed represents preferences of 100 individuals. What's the largest optimal membership fee charged to each consumer? Well, we still have identical demanders, so this is a really easy question. You're just going to set price equal to marginal cost, and then that's going to be the per unit price, and then find whatever is going to be the associated consumer surplus, and that becomes the fixed component. All right, let's do it. So here is the demand curve, 900 minus 15p. What's the highest quantity and lowest price? Well, the two-part pricing scheme would set price equal to marginal cost. But if price is equal to zero, that'd be the lowest possible price. Here we're interested in single price monopoly optimization. And so let's see. Here I have 900 minus Q is equal to 15p, or P is equal to 60 minus 15Q. Marginal revenue is therefore 60 minus 2 15th Q. Set equal to marginal cost of zero. This is just the revenue maximizing problem. And then I find a quantity of 450. The associated price is 30. There's just like a way easier way to do this. Way easier way is saying, wait a second. If this is my demand, and I want to find my revenue maximizing point when price is free, it's just the midpoint. So I'll look at this and say half of that is 450. That's my quantity. I'll look at this and say half of that is 30. That's my price. Or you could do it with the math. So, okay, if marginal cost is equal to 20, the competitive outcome, so then I was asking you, what does the competitive market do? Okay, what does the competitive market do? So let's set inverse demand equal to marginal cost. Price is equal to marginal cost. 60 is equal to 1/15th Q. So we'd get a quantity of 600. Now, my comment about the midpoint before is super relevant for this, because I was then asking, are you on the elastic or inelastic portion of the demand curve? And you're like, well, what do you do? The easiest way to do this, to answer this question, which is like, is this on the inelastic, unit elastic, or elastic portion of the demand curve? The easiest thing to do is like, let's find out where this lies relative to the midpoint of this demand curve. Okay, so if this is my demand, the midpoint is going to be at a quantity of 450 at a price of 30. And then the competitive market's producing a quantity of 600, definitely at a price lower than 30. So it's below the midpoint. Points below the midpoint in the demand curve correspond to the inelastic portion of the demand curve. Points above correspond to the elastic portion of the demand curve. I've got a video in my Q&A playlist that answers the question of why we call points at the top of the demand curve elastic. So you could go into the search bar and type in elastic, and that'll come up, and then you could get the intuition for that. So anyway, or if you ever wondered. So notice how the way that I built this question though was that by the time you solve this part and that part together, this part was straightforward without a calculation. So The other thing you could do is you could actually calculate some points, but I would not recommend that. Okay, so what's the monopoly outcome? Monopoly produces where marginal revenue equals marginal cost. Here we had a marginal cost of 20. My inverse demand is 60 minus 1/15 Q. Set that equal to 20. We find the quantity the single price monopolist would produce is 300. The price the single price monopolist would produce, well, go to the demand curve. Prices come from demand curves. The price will be 40. So our single price monopolist would sell a quantity of 300 at a price of 40. Our competitive market would set a price of 20 and sell a quantity of 600. The associated profit for our monopolist, well, price minus marginal cost times quantity would be 6,000. Okay, what about the two-part tariff? I mean, the calculation is pretty straightforward because we already have the price, right? So the per unit portion, that's just marginal cost. To find the fixed component, all we have to do is we have to find out what's going to be consumer surplus at the price of 20. Matter of fact, there's almost no calculation to do here because we already found the competitive market's going to produce 600. So I say from the competitive market, we know this portion of the triangle, 600. Then we're going to have the vertical intercept of my inverse demand curve, 60, minus the marginal cost of 20. Okay, so we're going to find consumer surplus would be 1,200. Clearly, this is better than monopoly pricing. Here again, we've doubled monopoly profits were this right here. Monopoly profits was 6,000. Here we get 12,000. So that's better than monopoly pricing. Okay. Another example. So suppose we have identical demanders, two-part pricing. We have 100 consumers. Inverse demand is given by 600 minus 120p. I did this one too. Good. Assume we have the market served by a firm with market power. Find the maximum and minimum. Here I'm just asking, like, what's the largest and smallest conceivable price? The smallest conceivable price is free. They're not going to pay you to take the product. And then the largest quantity would be the revenue maximizing quantity. That's all this is doing. Find the predicted output and price if the market's competitive and all firms are operating in the industry sharing a marginal cost of 2,000. Does this occur at the elastic, unit elastic, or inelastic portion of the demand curve? Find the predicted output and price if the market's served by a single firm with market power. Continue to assume all firms in the industry have the same marginal cost. And then suppose we want to do two-part tariff. Okay. So here's my market demand curve. Solving for my inverse demand curve, it's going to be 12,000 minus 20Q. What about the most for a single price monopoly? Well, let's find where the revenue maximizing point would be. The easiest thing to do is just say, okay, if marginal revenue is equal to 0, we got to find the midpoint of the demand curve because that's going to be the revenue maximizing point. So that's going to be what? It's going to be a price of 6,000 and it's going to be a quantity of 300. Okay, so we've got a price of, it should be price of 6,000, right? Oh, sorry. Yeah, is this right? Yeah. Price of 6,000, quantity of, I had done something wrong here. Yeah, I did. Yeah, price of 6,000, I lost a 0. Sorry. Okay, this needs to have a 0 right there. Good. That's annoying. Right, so my price is going to be 6,000. My quantity is going to be 300. We have to find where the competitive market would produce. Competitive outcome at the marginal cost of 2,000 would be a quantity of 500. 500 is going to be what? A larger quantity than the midpoint. So this is going to be in the inelastic portion of the demand curve for the reason I said before. It's below the midpoint if we were to draw out the demand curve. What's the monopoly going to do? They're going to produce where marginal revenue is equal to marginal cost. So we have 12,000 minus 40Q is equal to 2,000. Monopoly quantity would be 250. Monopoly price would be 7,000. Notice this is above the midpoint. So this is on the elastic portion of the demand curve, right? Smaller quantity, higher price. It's above the midpoint of the demand curve. What about with two-part pricing? We have the marginal cost already. We just have to find what's going to be the consumer surplus. That's because these are identical demanders. And so consumer surplus, it'll be 12,000 minus 2,000. That's going to be 10,000 times a half times 500 gives us producer surplus of 2.5 million. Okay. All right, now we can, I'm getting so bored. I'm so bored. There's a wide variety of topics that I refuse to teach because I get bored. And so I figure if I make myself bored with these topics, I can't pretend to make other people interested in them. So, but this isn't something I'm usually bored by. It's just 2 million of these questions. Yeah. All right. So this one's more interesting, hopefully for me and you as well. Consider a firm's optimal pricing decision as a monopolist with a marginal cost of 10 and no fixed cost. Suppose the monopoly faces customers all with the same demand curve. Q is equal to 80 minus P. Find the optimal two-part pricing scheme. Now, suppose half the consumers have demand. Quantity is equal to, I'm going to hide this part because that's the solution. Have the demand of Q is equal to 80 minus P. Half have demand 100 minus P. Find the optimal two-part pricing scheme. Continue to suppose half have this demand and half have this. Find the optimal two-part pricing scheme when both groups of demanders receive the same two-part tariff. I like this question. This is a really good exam question. I like this a lot. The first thing you have to do is you have to figure out what are part A, B, and C asking. Right? You have the tools, you have to figure out how to use them. So to be able to do that, we have to figure out what each is asking. Okay, in the first one, here we have consumers all with the same demand. Find the optimal two-part pricing scheme. Well, here I just have one group of demanders, so I have identical demanders at this point. Here you're going to set price equal to marginal cost, set the fee equal to consumer surplus at that situation. Okay, marginal cost is 10. So the price is going to be 10. The per unit price for part A is 10. Consumer surplus is going to be, well, 1/2 base times height. So price of 10. The vertical portion is going to be 70. Horizontal portion is going to be a quantity of 70. So it's going to be 1/2 times 49,000. So we'll see that. Now, suppose half the consumers have this type of demand, half have the other. Suppose we can offer a different access fee to each group of consumers. Give me the optimal access fee and per unit price. This is like where you have two different groups of demanders, but I can give them their own two-part tariff. Going from part A to part B, what's the additional calculation that you have to do? You have to find the identical two-part tariff solution for this demand. Why? Because your work from part A is your work for here. Right? Okay. So now we just have to figure out how we're going to price for this segment of the market. Now continue to suppose half the consumers have demand. Q is equal to here and Q is equal to here. Now we have both groups receiving the same two-part tariff, same access fee. Here's where I'm going to want to write out profit as a function of price. I'm going to differentiate and I'm going to find the optimal price, and that's going to give me the optimal per unit price and the optimal tariff. Okay, I'm going to skip over this part of the solution and do the one that I actually wrote out. All right, so when we have identical demanders, and this is my inverse demand, here's my marginal cost, right? We said this is 80, this is 70, this is 80, this is 70. Consumer surplus is going to be 1/2 base times height, or it's going to be 1/2 70 squared. That comes out to 24.50. So for part A, the optimal fee, 24.50, the optimal price, 10. All right, when we have separate demanders for part B, for these demanders, we did it already. So you don't want to kind of waste time doing that again. For this demand group, well, here's the picture. We're going to have consumer surplus is going to be 1/2 100 minus 10, because marginal cost is 10, and we'll have 90 here. Right? It's going to be 1/2 90 squared, or it's going to be like 80 100 divided by 2, or 40 50. So here we're going to set price equal to 10 again, and we're going to set the optimal tariff price, the optimal fee for these demanders is going to be 24.50. The optimal fee for these demanders is going to be 40.50. And that'll work if we're able to isolate them and separate them so that each is able to get their own access fee, and then they both pay the same per unit price. All right, so now with these demands, suppose we need to offer the same tariff scheme for two different demanders. Well, remember what you want to do here is we want to make the access fee based off of the demand for the smaller group of demanders. So I'm going to find consumer surplus on my smaller demand, which was this one, right? Consumer surplus as a function of some price. We're going to find out what this price is, but we know for higher and lower prices, right, this is going to change the shape of the triangle, which is governed by this formula. So my consumer surplus is going to be 1/2 80, the quantity 80 minus P hat or P bar squared. That's this right here. Let me write out my profit formula. Profit is a function of price. It's going to be 2 times 1/2 times this stuff. Why? Well, it's 2 because both consumers are paying the fixed tariff. So both consumers are buying. This is the access fee right here. Then this statement right here is my per unit profit from the low group. This right here is demand, right? Demand is Q is equal to 80 minus P bar, and this right here is price, or is the cost per the price portion, cost portion, price minus marginal cost. Here's my demand from my high group of demanders, and then here's again price minus marginal cost. So here's my per unit profit from the high demanders. Okay, so what I'm going to do is I'm going to take a derivative, and I'm going to find my optimal price. And once I found that optimal price, that's going to be my per unit price. Then I'll plug that back in, and I'll get my optimal tariff is going to be this right here. What's going to happen is my low group will definitely buy. My high group will definitely buy. I'm going to give up a little bit. This amount is going to be smaller than that 24.50 from above, right? Because this price is going to be higher than 10. So we're going to get a smaller tariff than we could have, actually from both groups. But we're going to make it back on the per unit profit, because now the per unit profit's not going to be 0. It's going to be whatever is this gap right here. And I'm going to get that from both groups of demanders. Okay, so as I've written this out here, I did something really clever from the standpoint of taking this derivative. You'd completely undo this by the other thing you could do is you could distribute, you could FOIL, and then take a derivative. I just think it's algebraically more challenging. Here, I think, is the computationally less and least intense way to do this derivative. So let's deal with this right here. 2 times a half, that's gone. Take the derivative here. We'll bring this 2 out front. Reduce that power by 1. And then this minus 1, chain rule, so that's from this right here. Okay. Now as I'm staring at this, I'm going to say, okay, I'm going to do product rule here. When I take a derivative with respect to p hat, I'm going to get a 1 times this stuff, and I'm going to get a minus 1 times this stuff. So let's do that. So here's this stuff times that 1. And then here's this stuff times that minus 1. Oh, I can take care of that just by flipping the sign. I'll write this as 10 minus p. And I'm going to do the same thing over here. Derivative with respect to p, it's going to be this stuff times a 1 here. And then I'm going to take a derivative of this with respect to p. I'll have a minus 1 times this stuff. Right? That's that. Then solving, just summing up. And kind of like what I like to do is I stare at the things that have the p in it, and I kind of collect those visually. Okay, I've got 2p bar. That's quick. And then I'm going to look at, what I like doing is I like adding up all the positive things first. So, okay, I've got a 10, an 80, that's 100, plus 100, that's 200, minus 160, that's a 40, right? So price is going to be 20. That's going to be my optimal per unit price. And then I'll just evaluate this expression here at a price of 20, and that'll give us our optimal access fee of 1,800. And that's all you got to do. Okay, let's see. Okay, so I might as well walk through this one. This one got broke off. That was bad. All right, so we have 2 groups of demanders. Now I'm going to do number 14. Consider your optimal pricing decision as a monopolist with marginal cost of 14 and fixed cost of 400. That changes things a little bit because the one before didn't have fixed cost. From the standpoint of the derivative, if we had fixed cost, we just append that at the end here. That'd go away when we take the derivative with respect to price. And then we said, suppose the monopolist determines half its customers have demand of Q is equal to 90 minus 3p, half have Q is equal to 120 minus 4p. Find the optimal 2-part pricing when it's possible to offer a different access fee to each group of demanders. Oh, this is where I'm able to separate them. I'm going to do individual pricing for these 2 groups. Continue to suppose half have this demand, half have that demand. Find the optimal 2-part pricing scheme when both groups have to receive the same 2-part tariff. So this is where I'm going to have to write profit as a function of price, just as we did before. Okay, so I didn't write out this thing by hand. I just added some other stuff here. So the first thing I'm going to do is I'm going to translate this from a demand into an inverse demand, which is what we'd graph. So it's going to be 30 minus 1/3 Q. And then here's the picture. And I'm going to make this 30 minus 1/4 Q. And here's the picture. Okay, so in the first part, we have our demanders, we can separate them. We're going to set price equal to marginal cost in each case because I have two groups of homogeneous demanders that are separated. And I'm going to set the tariff, the fixed fee, equal to their consumer surplus at that price of 14. So basically what this amounts to is, the price is going to be 14 in both this group and this group because that's just marginal cost from before. And then the associated fixed fee is just going to be whatever is consumer surplus here. So it's going to be 30 minus 14 times 48 times a half, and that's 384. And then over here, it's going to be 30 minus 14 times 90 times a half, or 512. So my profits are going to be this 896, like summing these things up. We have fixed costs. So profits are actually 496. Right. Next part. Well, technically, we'd have to verify we don't want to just serve either the high group and then profits are 112, or the low group and then profits are 368. So what do you do there? Okay, so part B, find the optimal two-part pricing scheme when both groups get the same two-part tariff. Okay, so we have kind of a couple options. One is, let's just set the access fee equal to whatever my high demanders are willing to pay, and then we'll ignore our low demanders. Find out what the profits are there. Then find out what happens if we set the access fee equal to what our consumer surplus of our low demanders. Double that profits, because we'd be able to get that from our low group and from our high group, and see what that is. And now we're comparing this to the situation where I'm going to write out, I'm going to make this same expression we had before, profit as a function of price, take a derivative, and then find the optimal price and the optimal tariff. So, all right, here is going to be my low group of demanders, right? So when I'm going to find the optimal, price for my my two groups of demanders, I'm going to write the access fee equal to consumer surplus of my low group at whatever is that optimal price. So an expression for consumer surplus as a function of this price is going to be 30 minus whatever is this price. Here the demand is going to be 90 minus 3 times that price, or 3 times 30 minus, or 3 times the quantity 30 minus P. That's actually huge that I did that. So why? Okay, well, consumer surplus is going to be 1/2 times 30 minus P times 90 minus 3P. Here I factored out a 3, and I wrote this as 3 times 30 minus P, which allows me to write this as the consumer surplus expression as 3/2 the quantity 30 minus P squared. Then I'll drop this into the profit function. That's going to be this right here. Here's my per unit profits from my low group, price minus marginal cost times demand from the low group. Here's my per unit profits from the high group, price minus marginal cost times demand from the high group, minus 600. Okay, and then here I take the derivative. So basically to do that, you just write this there. Whoops. Take a derivative and you'll find out the optimal price is going to be 16. Computing profits, the profits are 384. Yeah, we're better off with this than the other two options, which was selling only to the low group, or selling to the high group only, or selling to both groups at the price of the low group. Okay. All right. Let's see. I should do this one. So consider your optimal pricing decision. When your marginal costs are 10, there's no fixed cost. There's two types of consumers, casual and hardcore. So the monopolist estimates casual demand to be 90 minus P. Hardcore demand is 180 minus 2P. Suppose the firm decides to set a price of 10. Assuming the monopolist must offer the same tariff to both groups, find the optimal tariff. Oh, they're setting price equal to marginal cost. We have to offer the same tariff to both groups. Find the optimal tariff under these conditions. Okay. Suppose the firm no longer necessarily restricts itself to setting price equal to 10, simply must offer an identical price and tariff to both casual and hardcore consumers, solve for the optimal tariff profits, per unit profits and total profits, and suppose we're actually able to offer different tariffs to each of the consumers. Remember how I said the big thing is you have to figure out what you're doing in each of these cases. Here, I've given us a price of 10. We have to offer the same tariff to both groups, so there's two things you could do. One is you could set the access fee based on the demand of my low group, or I could set the access fee based on the demand of the high group. And I'm going to check those two situations, and then it's going to tell me which is going to be optimal, and that's going to be what I'll do in part A. Then part B, this is going to be where I'm going to come up with the optimal access fee to be based on the consumer surplus of the low group at whatever is that optimal price. And then part C, suppose I'm able to offer different tariffs to each group of consumers. This is where I can separate them. Well, that's where I'm going to have two different homogeneous groups of demanders. So I'm just going to set price equal to 10 in both groups, and then find the consumer surplus in each of the two segments, and then that's going to be each's respective access fee. Okay, so in the first one, part A, must choose to serve casual and hardcore or just hardcore. Per unit profits are just zero regardless, right? Because you're setting price equal to marginal cost. Tariff profits from serving casual and hardcore consumers are found from doubling consumer surplus of the low group at the price of 10. Consumer surplus for the casual demanders, well, it's going to be 3,200. So the tariff and total profits are 6,400. Why? Because we double this. We sell this to the low group and to the high group. If we only sell to the hardcore group, the profits are just the tariff profits from the hardcore group at the price of 10. Here, it's going to be 1/2 80 times 60. Where's this coming from? Well, draw the inverse demand. It's going to be 1/2 base times height. This is our quantity. This is our whatever is the price. Okay, either way, the profits are 6,400. That actually gives us the answer for down here, right? Because if this is going to be my tariff for my hardcore group, or my access fee for my hardcore group, and this is my access fee for my casual group, and I'm able to keep them separate, that's what we're doing in part C. So then my profits are going to be 9,600. Okay, so notice, for the way I structured this question, by the time you did part A, you'd actually had part C done. Right. So part B, this is where we have to offer the same price and access fee to both groups. Write profit as a function of price and find the optimal price. So here I want to write I'm going to write the access fee equal to consumer surplus of my low group as a function of this price. So it's going to be 90 minus P squared times 1/2 times 2. Why? Because both are buying. Here's the price minus marginal cost. Here's my quantity from my low group or my casual demanders. Here's price minus marginal cost. Here's my quantity from my high demanders. And then again, I'll take a derivative. So the way that I'm doing this, I'll have, well, this becomes 1, then I'll have this 2. This minus 1 comes from chain rule. And then over here, I did this a little bit different I didn't do this like I usually do. I took price minus marginal cost times this minus 1, okay? And then I'm going to take this times that price, okay? And then over here, I'm going to have price minus 10 times a minus 2 here. That's this. And then here I've got 180 minus 2p times a 1 here, right? That's what I was doing there is just product rule. Solving, you find a price at 30. That allows us to find the optimal tariff or optimal access fee profits, because I'm going to drop this 30 into this expression here. And I'm going to find that's 1,800 from each group, or 3,600 total. That's small. However, we're getting per unit profits of, well, this right here boils down to 1,200 at a price of 30. And this right here boils down to 2,400 at a price of 30. So total profits are 7,200, which actually isn't very bad relative to part A, right? Okay, very good. And then let's see. Might as well just do this last one. All right, so two groups of demanders. Suppose the monopoly faces customers all the same demand. Q is equal to 50 minus 5p. Find the optimal two-part pricing scheme. Give me your optimal access fee and per unit price. Suppose half have this demand, half have this demand. All right, suppose half have this demand, half have this demand. What's going on in B? Well, here you have to give a different access fee to each group of demanders. So that's where that's the more complicated one, as we just did before. So we're going to write price. We're going to try to find the optimal price. My contacts I can't hardly see anything, so that's why I'm getting super annoyed. Here is where they have to have the same two-part tariff. And then here I had a demand. Suppose your low demanders, there's new growth in size of the market. So the number of potential customers expands. So you now face these demand curves. Redo part C with these new demanders to find the single best access fee. What happens? Why? That's clever. Okay, well, this is fun. All right, so in the first case, this is just, we have one group of demanders. And so we're just get your inverse demand, set price equal to marginal cost. Oh, marginal cost was 0. So just find whatever is the area of that triangle, and then that's going to be the access fee for part A. Okay, so set price equal to marginal cost, extract surplus via the access fee, consumer surplus at a price of 0 is going to be 1/2 times 10 minus 0 times 50, or 250. Part B, this is just a two-part tariff for identical demanders twice. We'll isolate the groups and offer each their own access fee. Is that what I was really doing there? Suppose half of the demand, half of the... Oh, it's possible to offer a different access fee to each group. Yeah, so we have different access fee to each group. Here we can keep them separate. Okay, well, we already know what's going to happen here. It's going to be that 250. And then we just have to find what we're going to do here. All right, so price is equal to marginal cost, which was 0. So we had 250 for the first group. And then we just need to find the area under the second curve. So 1/2 times 20 minus 0, or times 100, gives us 1,000. All right, so this is where you're able to isolate those two demanders, give them each their own two-part tariff. Right. Consumer considers... Continue to suppose half have this demand, half have this demand. Find the optimal two-part pricing scheme when both groups demanders must receive the same two-part tariff. This is the more complicated one, where I'm going to write the access fee as a function of price. So I'm going to take consumer surplus of my low group as a function of price. So it's going to be 5 times 10 minus p squared times 2 times 1/2. Okay, what's going on here? This 2 is because both are buying. This 1/2 is because the area of the triangle is 1/2 base times height. This 10 minus p, that's happening because when I get my inverse demand, it's going to be like 10 minus p. Yep. And then my demand itself, we end up factoring out. I think I ended up factoring out. Oh, this is my low group of demand. Yeah, I ended up factoring out a 5. Okay. Right. So then this is just... I can't see this. Right. So this is after I've taken the derivative. Yes, this is after I've taken the derivative. This boils down nicely. This is that one from chain rule. And then this is just from this stuff here. Cool. This boils down to a price of 5, and then consumer surplus for the low group is 62.5. And then that ends up being the access fee. Let's see. And then for part D, I said, suppose the low group gets bigger. So we went from... this, we 100 minus 5p to 100 minus 10p. Okay. And 100 minus 10p. I don't know. So this ended up, so you'd have to run through this. I don't know. My vision's super blurry right now. Ended up getting a price of 0. Consumer surplus of the low group is 500. Get that from both, or can simply serve the high group. Either way, probably. Yeah, sorry. I'm gonna stop. Can like or dislike or whatever you need to do. I don't care.